Hi, thanks for joining me. My name is Heidi Schran, and I teach secondary school science at Talawanda High School in Oxford, Ohio, in the USA. And I'd like to share with you an amazing opportunity I had last April with doing some authentic research with my astronomy students. Actually, it was all of last year. So who we were a group of 9 students, 2 of them college students, 7 secondary high school students, age range 15 to 19. And then there I am second to the right, and Joanna Hohn was the STEM outreach coordinator for Miami University of Ohio on the far right. And Joanna had found the grant opportunity and suggested that I apply for it. And she was like my SAG help throughout the process. And then we are located in Oxford, Ohio. There is a picture of the US map. Ohio's in the eastern side of the middle. And Oxford is the far bottom left town on that picture in the center. The 2 blue lines are the path of totality. And where we got to experience 2 minutes and 53 seconds of totality last April. It was amazing. So where did the money come from? Well, Cosmic Pictures is an IMAX group. They make documentaries in the IMAX format, and they got a National Science Foundation grant to pay for a lot of different things, in part our research and our training of our students. The money went to both the National Girls Collaborative Project, which it helps to further young women in their skill sets and in STEM and out of STEM. And then the Dynamic Eclipse Broadcast Initiative at Southern Illinois University. They did all things technical with getting the equipment, training folks with the equipment, getting the programs to take and process the data. And they have already run in 2017 a citizen science research initiative just like this one. And they had a total of 80 teams, 20 of which were part of the grant that I got to be part of. And we, at the bottom there, you see us all in Cleveland. There were 20 team leaders met in Cleveland in November, and we got trained on the equipment. And there we are again. And on the right, you see our equipment. It's a digital telescope, so there's no eyepiece, but the red hexagon at the bottom there connects directly. It's a camera directly up to a laptop they provided with us. And they provided the mount, the tripod, the programs on the computers and everything. And they trained us on that. And as a novice, I went back and my goal was to train the students on my team, collect a team and train them by April on how to run it on their own. So we practiced through the winter. A lot of times we had to practice inside my classroom and during and after school because it was too cold outside to practice. But some of the time we were able to go outside when it wasn't too frigid and set up the equipment. And you can see us on the right there, all bundled up. It was probably mid-February, and we would not just have single practices on our own, but would also connect up with our the total of 20 groups would connect up at the same time. And folks would communicate through Discord, which was a learning curve for all of us, and get us to all practice as if it was Eclipse Day and we're all doing it at the same time. And that helped the folks at Southern Illinois University to rehearse their job as well, collecting all that data at once. And those are some of the images our team took during our practice sessions. As we got closer to the eclipse, there was a lot of media coverage, and that gave my students a chance to practice their public speaking skills and to share their knowledge and even cement it more and master it more by having to share it. And we had multiple newspaper interviews and at least 5 different television interviews coming up right before the eclipse. We did some outreach events as well. We had a eclipse program at our local library, and some of my students went to a local elementary school to share how to watch the eclipse safely with second graders. And then the weekend before the eclipse, our town had a celebration of the eclipse up in the center of town. And we brought our telescope up and set up ways to watch the eclipse safely. My students helped community members build pinhole viewers. And we had the one last really good practice before the eclipse. And so we had the telescope there and could share with the community that stopped by some of the images that we were collecting of the sun that day. So on Eclipse Day, we all got to the high school, which was our place of practice and our place for the Eclipse Day. It was away from crowds. There was no school that day. It was canceled so that students could be at home watching the eclipse, but my team came to school and worked longer than a school day on the eclipse. And we also had a watch party, so we invited family and friends, but we knew that they would allow us to get our work done. But we did have lots of folks come by and ask us questions that were in the area. So before and after totality, our students had the job of running the partial programs. Partially eclipsed was where it gets its name, but it would take multiple images every minute and then get rid of any errors in the images and make a really crisp image every minute during from first contact up to totality, and then after totality to last contact. During totality, or right before, they had to cover the lens of the telescope and remove the solar filter, and then start a whole nother program. And then when it was time, allow that program to capture the sun during totality. And this program collected images at 4 different exposures, rapid fire right through. And when we first ran it, we thought something was wrong with the program because the screen would get super bright. And they're like, that's what it's supposed to happen. We're like, okay. And then when we're all said and done after the day and the eclipse was all over, we still had 2 more programs to run. And those were to get rid of any artifacts that were on the lens or in the program or in the camera. Sometime in March, we were offered the opportunity to live stream video of the images we were getting that day. And our team said yes. And so I had 2 students just take the reins on this. They set up the equipment when we first got it and took it out of the case and figured it out, made their own labeling system with different symbols and instruction sheets, and it was just amazing. That's them there setting up the streaming site, and I had all different programs and different equipment that the group had to get comfortable with, and they just mastered it and were great. And then other team members spent the day, we called it babysitting the telescope. They watched to make sure that the image didn't drift out of view and that it didn't get out of focus. As it heats up or cools down, the lenses can change shape and it can get slightly out of focus. Make sure the exposure was correct and that they were running the correct programs and all of that. And on top of that, they continued to educate. That's a picture of our watch party there. And on the right, you have one of my students sharing with my grandson how you can use a colander to look at the sun before the totality safely. One of the main goals that I had to share with my students was the joy of doing science research. And it was a huge commitment for them. They are at school from 7:30 in the morning till 3 o'clock in the afternoon. And then many of them have sports or activities or in multiple sports or activities afterwards. Some of them were doing college visits at this time as in that spring. Some of them were gearing up and took the ACTs just before this. So they were very busy students and put a lot of time to learning and mastering and being comfortable with the equipment outside of the school day on their weekends. And then there was a lot of things that were out of our control, such as the weather. There's a screenshot of the weather app for today would have been April 8th, the day of the eclipse. And every day afterwards was raining, but that day was sunny and 76 Fahrenheit, which in Oxford, Ohio, on early April is a very rare thing. And the newspaper had the weekend before forecast of snow over the weekend. So it was just an amazing stroke of luck that we got to have the weather that we did. And this picture is something I wanted to share with you all. Joanna Hohn, the woman from Miami University, captured it and shared it with me. If you zoom in on my students, they are just elated and having a great time while in the middle of or towards the end of their long workday. And then there's one of my students who's focused in, she's locked in, she's got the screen and she's doing her job. And you can see on the screen that it's just a sliver of the sun left right before totality. And on the right, that's me. And I was just so excited and so just delighted that everything had gone so well that I was hopping up and down. I was so excited. And I was so glad that Joanna had captured this picture because I don't know if I would have remembered that I did that. After the eclipse, we had a data party. And during the data party, I shared some of the data that we had. And the students got to look at the images. We shared pizza. We got to chat a little bit about some of the fun things that were coming up throughout the rest of the year that they could join me with the telescope and still get to use it and have fun. And then Alice and Alan from the Rockman group came and conducted some student interviews to find out how their relationship with science and STEM and research and career options had changed throughout their project. And it was just great to hear their responses. They just all had a wonderful time, and I couldn't have been more delighted. This is some of the data that we had collected. I wanted to show you what it looked like. This was from the totality images before totality. I'm sorry, partial images before totality. And you can see two sunspots prominent in the center of the sun. And then our data, we were lucky enough to have it be used as the baseline data for not just the 20 groups that got the grant, but there were actually a total of 80 groups in the Dynamic Eclipse Broadcast Initiative. And they used our data, the two sunspots, to orient others' data and overlay the images so they were all be in the same orientation. And then this was an early processing of one of our totality images or some of our totality images because they would stack the rapid fire images on top of each other with the different exposures. So you're able to get not washed out corona right above the sun surface and still see all the tendrils as you go out. And then with more further processing, they can get rid of some of the noise and adjust it so that you can get nice crisp images. And so Southern Illinois University is still working on those. And I just want to leave you with this image here that I love so much. And I would love to chat with you some more, answer any questions. And thank you very much for attending and listening.